So now what we're going to get, so now we'll have x is going to be 1 minus u, and then we'll have u cubed du. We have a minus, but when x is 0, u is 1. When x is 1, u is 0. So let's flip the limits and change the sign. Okay. So now we're integrating from 0 to 1. So now we can distribute, and we get u cubed minus u to the 4th du. And now this is something that we can easily do. So u to the 4th over 4 minus u to the 5th over 5. So we get 1/20th, and I forgot something. There's a 1/6 that was sitting out here all this time. So 1 over 1/20th is the final result for that. All right. Okay. Questions on setup or evaluation of that one? All right. Now, okay. Now there is enough.
1 over 120.
Oh yeah, that's the final result.
But how? Because if we did 1/4 minus 1/20th,
Oh,
we'd have to get a common denominator.
That should be 1/5 there.
Oh, okay.
Okay, yeah. Typo in the notes, the second to last step, it has 1/4 minus 1 over 20. That should be 1/5. So this is page 3. I think I'd meant to do an intermediate step where I'd have 5/20ths over 4/20ths, and then I scrapped it. Yeah. So it's, yeah, the second to last step.
That times 1/6, that's outside of the interval. That would be on the other side, right?
Yes, yeah, I wrote on the other side. I just didn't want to squeeze it in here. Yeah. Sadly, a lot of what I do or way I write things is for formatting convenience, or like to prevent the notes from spilling onto another page. All right. Okay. Any other? All right. Now there is a number in the notes, but I'm going to do one that's not in the notes. Okay. Here we go. Oops. Awesome. Okay, so this is from Stewart 12.5, number 15. Okay, so is that the one I wanted to? Yeah, okay. So the integrand is simple enough. You're just integrating x, but the region is bounded by a paraboloid. X is equal to 4 y squared plus z squared, and also bounded by the plane x equals 4. Alright, hopefully I can at least do this. I can definitely do at least a setup of this, which is the main reason why I'm doing it. So if we draw what's going on here, so the paraboloid, it's going to run along the x-axis this time. It's going to look something like this. So for each x, you're going to have have circles of increasing radius. Okay. So, at x equals 4, then we have a plane that marks the right boundary, if you will, of the solid. So, in this case, it's easiest to express this solid as a difference between surfaces that define x as a function of y and z, as opposed to coming with bounds in z as functions of x and y. So, so what we could do is the left bound. All right, thinking of the x-axis as going from left to right, is x is equal to 4 y squared plus z squared. The right bound is the constant function x is equal to 4. Okay, so the triple integral x over this solid we can now write as a double integral where this will be our lower limit for y squared plus z squared, because this is where the x coordinate is less, up to 4, this is our integrand, dx. So this is our inner integral. And then we have a double integral over the region D. So we need to come up with an idea of what this region D is. So for that we need to see what happens when these surfaces meet. So where the paraboloid meets the plane x equals 4, what can we say about y and z? Yeah, y squared plus z squared is equal to 1 at this boundary. So our region D, instead of all y and z, so y squared plus z squared is equal to 1. So by looking down the x-axis at this region, so we're looking at this portion of it,